Okay, this is just a short little video taking us through the MAT 2011 short questions A to E. I don't claim that these solutions are the best ones. These are just simply my way of doing it. I hope they make sense. And I hope there's no mistakes in it. Do let me know if there is. Okay, so let's just get straight on with it, shall we? This was quite a nice starter question, really. Certainly more comfortable than B, which we'll look at in a second. But really, I guess if you're doing a question like this, you could immediately rule out B if you like, because it goes through -1, but clearly here when x is 0, y is 1. But really, this is just typical factor theorem, isn't it? Because we've got all the factors and we can easily decide what the cubic looks like. It's a right way up cubic as well, which means actually it's really just out of C and D, because this is like a negative x cubed, or a negative x cubed look like, and we've clearly got a positive x cubed. Anyway, they do expect you to be able to spot really straightforward factors like 1. And clearly here, if we plug 1 into this, we're going to get 0 popping out because we're going to have 1 minus 1 minus 1 add 1. Clearly that will give you y as 0. Hence, and remember, you haven't got to write down any decent working here. X minus 1 is a factor. And now you need a way of quickly dividing. Personally, I'm a big fan of the grids. I don't bother with long division anymore. I find long division tedious. And so I just think, well, I need an x squared to make the x cubed. That gives me a minus x squared as well. Good, I need that. I've got that term now. And then I need a minus x, so I'll just have -1 here, because that'll give me minus x and plus 1. Look at that, I've divided it, so I can see y equals x minus 1 times by x squared minus 1. Well, that's x minus 1, x plus 1. And so what have we got here? We've got a repeated factor, so it must touch at x equals 1 and go through -1. And so the answer is C. That one really shouldn't take you more than like 45 seconds to a minute. And you need that time, remember, because you get an hour to do these 10 questions. So that's 6 minutes per question, isn't it? Well, if you can do some of the questions a lot quicker than that, that's obviously a really big bonus. Okay, so we'll move on from that. Now, this question, this is a kind of question which can really confuse. There's no doubt about it, because you kind of look at it and you think, you might feel quite optimistic at first. So you think, okay, well, I know what a rectangle is, and I'm going to call my rectangle's length x and this one y. I know that P is therefore going to be 2x plus 2y, and I know that A is going to be xy. But the big question is, how do you get an inequality out of this? You should always be trying to spot, when they're asking for an inequality and when they're asking for equality in equation. But when they ask for an inequality, ponder why, how are you going to obtain an inequality in the working? When do we get inequalities? We get them with discriminants. We get them in certain situations with maximums and minimums. That's kind of like the big question you want to ask yourself here. Yeah, which has just occurred to me. Maybe I could do this with calculus, and I think I probably can. But I think the way they probably wanted you to do it was, well, we've got no x's and y's obviously in our answer. Let's try eliminating one of the letters. X is clearly a over y here, so we could say P is going to be 2 times by a over y. X is a over y, isn't it? So 2 times a over y plus 2y. Remember, you don't have to be neat in this part of the exam, because you can be really messy, because all that matters is the final answer. That's going to give you yp is 2a plus 2y squared. Now, if you consider this a quadratic in y, we can then keep going and say, okay, so what have I got here? I've got 0 is 2y squared minus py plus 2a. Now remember that y should certainly be real. It can't be an imaginary number. We can't have an imaginary number representing the side of a rectangle. And so we can use the fact that the discriminant for our quadratic is going to be greater than or equal to 0. And that's kind of good, because I've got now an inequality. Yeah, and that's what I mean by going from equality into inequality. What's my b here? It's p, and that's what really makes you think, oh, I'm probably doing this the right way, because I end up with p squared. And then you're going to be doing -4 times by 2 times by 2a. Lo and behold, we get our answer that p squared is greater than or equal to 16a. Quick word about this. I'm convinced that you can do this with calculus. I'm not going to try it now because I'll probably mess it up live. But another way I thought of doing this, the AMGM inequality. If you're familiar with lots of math challenges, like the later rounds, they often use the AMGM inequality. What on earth am I talking about? This famous little result, particularly the two in the middle anyway, this is the root mean square value. This is a arithmetic mean, this is geometric mean, and this is harmonic mean. But this is a very well-known set of inequalities which are particularly useful for problem solving. But the middle two, and actually the result is bigger than this, and you can do this not just for A and B, but A plus B plus C, over 3. It's the cube root of A times B times C. There's much longer results which you can use. But just using this fact being always true for any real numbers A and B, you can actually get the answer much quicker in a sense, because we've got perimeter is 2x plus 2y, and we've got area is xy. And so what we could do is we could say, okay, well, I already know from the AMGM inequality that x plus y over 2 is going to be greater than or equal to the square root of xy, because this works for any two real numbers. And naturally, the length and the width of the rectangle can be any two real numbers. Well, positive real numbers, should I say. All I need to do now is kind of recreate the 2x plus 2y. So if I times both sides by 4, I'm going to get 2x plus 2y is greater than or equal to 4 root xy. And now I can just like plug in what I've got here, because I could like point out that this means that p is going to be greater than or equal to 4 times the square root of a, and therefore square both sides. And I can safely do that because both sides are positive, so I don't have to worry about any negativity around the inequality. And I get p squared is greater than or equal to 16a, which I believe is the same answer I got before, which is part C. So there we go, 2 C's to start with. Hope that one makes sense. I must admit though, this is the kind of question you can faff around a lot on and suddenly like get in a bit of a fluster, like why am I finding part B so difficult? You don't mind it on H, I, and J, but part B, you kind of feel like, oh, I should be getting this one right just as quick as the first one. Okay, this one, the sequence xn is given by the formula xn is n cubed minus 9n squared plus 631. The largest value of n for which xn is bigger than xn plus 1. Well, straight away, I'm writing down xn as n cubed minus 9n squared plus 631. Well, that needs to be bigger than x subscript n plus 1, which just means we're trading all n's for n plus 1s. So let's write that out. Now, when you see this, you should be pretty happy. Firstly, the 631, so clearly, just a distractor. Stick any number in there, that would do. Like, I'm sure they're going to make another question, just say stick 631 on the end, that would do. But now we've got, especially after you expand these brackets, and you definitely want to be confident with expanding brackets on a cubic, a repeated cubic factor. Just use Pascal's triangle. We're going to have plus 3n squared plus 3n plus 1. You want to be quick with doing those kind of things, and certainly this one as well, minus 9n squared. You're going to get 2n times 9, so that's going to be minus 18n. And then you're going to get 1 on the end, so minus 9. Now, what have we got here? Look at this, and the n cubes cancel, the minus 9n squareds cancel, and you're left with a quadratic inequality, which you should be really comfortable with solving. We've got 3n minus 18n, so that's minus 15n. And then you've got 1 minus 9, well, that's minus 8. Now, the one downside here at this point in the question is you realise this doesn't factorise. You might quickly ask, how do I know it doesn't factorise? We'll always check b squared minus 4ac, which should be a nice kind of squarish factor. It's something easy to square root if it factorises. And actually, as it happens, b squared minus 4ac is not a nice number. But remember, we're just looking for where this quadratic lies underneath the x-axis, and we need the largest value of n. Yeah, if we consider this like a y in terms of n quadratic, like we are looking for where this quadratic is underneath the n axis. Yeah, and also we know n is an integer, obviously, with these. Clearly n is an integer when you're dealing with these kinds of sequences. It's a positive integer, in fact. And so I know I need that value there. Now, if you consider that quadratic, you're going to have like n equals, and I'm just using the quad formula here, minus b plus or minus the square root of b squared, yeah, minus 4 times 3 times minus 8, which is 12 times minus 8, which is going to become, well, you're going to end up adding 96 to 225. And that gives you 15 plus or minus root 321 over 6. Yeah? Now, what you want to think here is, what is the square root of 321? Well, it's not obvious what the square root of 321 is. So find a big square number nearby, because we don't need great accuracy here. We just need to find the biggest whole number just underneath this number. Now, square root of 324 is 18, last time I checked. And so I'm going to have 15 plus 18 over 6. Obviously, you don't worry about the minus one because it corresponds to this one over here. Maybe that's on the negative side. Yeah, it will be on the negative side. So I've drawn my diagram wrong. It's actually going to be over there. But we don't care about this one because we're trying to find the largest value of n for which the inequality holds true. And this obviously equals 33 over 6, which is 5.5. And so the largest value of n, where n is a whole number, is 5. Bit of a fiddle at the end there because it didn't factorize. It's always a bit annoying. But there we go. This one's also a bit fiddly as well. Naturally, if we're trying to find the fraction of the interval, leave that up, the fraction of the interval for which sine x is greater than equal to half and sine 2x is greater than equal to half, it's pretty clear to me you obviously want to draw out sine x and sine 2x to find out what on earth is going on. Yeah. Now we've only got it for the typical interval, 0 to 2 pi. Now I hope this is going to look nice when I draw it, but it probably isn't. Doing it on a graphics tablet, I'm not great on these things. Okay, that's pi, and that's 2 pi. The thing is, the nicer you draw this, the less likely you are to make sort of blunders, like mistakes with the way you've drawn it. I wonder if I can actually change like the style of the pen here. Can I change the colour? I could. Oh no, smart drawing. No, it all goes wrong with any smart drawing. Smart drawing ain't that smart. Okay, let's just try and draw it like this. Obviously, sine 2x is going to be a compression, scale factor 2, in the x-axis. Yeah. So you're going to repeat twice as many here. So you're going to have something like that. It's not perfectly drawn, but I think it's a serviceable diagram. Okay, that's y and this is x. Now, we're looking for the critical values, if you like, or where the line y equals a half is. Yeah, so let's just draw a line representing y equals a half in this. Oh, no, no. That's smart drawing stuff again, I don't know. Let's try once more to draw this line, otherwise I'll do it by hand. No, no. Maybe I can do it like this, yeah, maybe. Okay, so that's my line y equals a half. Now, if you look carefully at the question, we're looking for the fraction of the interval for which one or both of the inequalities is above a half. That gives us quite a few possibilities, yeah? Initially, neither of them are above a half, but sine 2x gets to a half, okay? So it'd be useful to find that value. Then we're both above a half, or at least one of them is above a half, all the way up to here. Then they're both below a half. And then here, one of them is above a half, and then here, they're both below a half. So clearly those are the crucial values, yeah? In other words, I need to find, to satisfy that condition, that one or both are above a half, I need those values there, and I need these values here. Now remember which one you're dealing with. The squashed one is sine 2x, and the non-squashed one is sine x. Now, sine x is only critical for that value, but sine 2x is going to be critical for that value, and that value. So let's solve sine 2x as a half first. Now, you've got to know these. You've got to know these at the back of your hand. Sine 2x is a half when x is pi over 6, 30 degrees, if you prefer working in degrees and then convert it to radians. Now, whenever you do an inverse sine, you do pi minus your first answer. So that gives you 5 pi over 6. And then for the next few values, all you need to do is add 2 pi each time. So 2 pi plus pi over 6 is 13 pi over 6. You don't want to be faffing about here. 2 pi plus 5 pi over 6 is 17 pi over 6. Yeah? Remember, no calc. So x is going to be pi over 12, 5 pi over 12. And I know I don't need all these values, but I'm just being systematic here. 13 pi over 12 and 17 pi over 12. Now, what values are these? They're the values here, here. I don't need the 5 pi over 12, in other words. Here and here. So that is pi over 12. That one is 13 pi over 12. Let's squeeze that in there. Kind of messily. This one is 17 pi over 12. Okay, I still need this one, and this is for straightforward sine x. And if you look what we did up here, that one's actually going to be 5 pi over 6. Because all you're going to be doing there is sine x is a half. So x is pi over 6. Well, we don't need that one. That corresponds to this one here. Or 5 pi over 6. Well, we need that one, which corresponds to that thing there. Okay, so if we're finding the fraction of the interval for which one or both is above a half, then I need to do 5 pi over 6 minus pi over 12. Quickly do it in your head. That's 10 pi over 12 minus pi over 12, which is 9 pi over 12. Keep it. You can simplify it in a minute. That's that gap. This gap is 17 pi over 12 minus 13 pi over 12, which is 4 pi over 12. Add them together, you're going to get 13 pi over 12. Now you need to find what fraction of that is of that interval 2 pi. So if we divide this by 2 pi, we should have the answer. 13 pi over 12 divided by 2 pi. Well, you're dividing by the pi, so they cancel, and then you're halving it essentially. So that's 13 over 24, and the answer is B. Yeah, bit of a faff that one. Tell me if you think you've got a quicker way of doing it. I can't see a quicker way, but just one of those kind of faffy ones. It's not difficult to do, it's just a bit of faff. Okay, this last one. Well, I did this one the other day when I was in the dentist's, suffering from a tooth abscess, which is very painful. I made such a faff around of it. I really did. It was quite funny, really, how long this took me, because this looks to me like the typical kind of way we prove kind of compound angle formulae and stuff like that, except it's slightly different because you've got this circle involved, and that makes it slightly different. But the diagram, yeah, has these angles. Well, why can't we call this length 1? Because even if the length was 3 or 4 or 5, they're not specifying that length. And it really helps your trig if the hypotenuse is length 1. Because then, of course, this side will become sine alpha. And just in case you're wondering, that side will become cos alpha. But once you've got that as sine alpha, we can start working with this. Because this is a radius of a circle. So this side is going to be sine alpha as well. Yeah, and then remember, okay, we haven't got a right angled triangle, but trig works in non-right angled triangles as well, particularly sine rule and cosine rule anyway. So we can now use kind of sine rule, and we can say that sine of this angle, sine of beta, divided by its opposite side, sine of alpha, equals sine of this angle, well, that's sine of gamma. Oh, I've drawn alpha instead of gamma, apologies. Try and make your gamma look different to your alpha. Sometimes I find my gamma almost becomes my alpha, and that's dodgy. Divided by the opposite side, which is 1. And now I can easily rearrange that into the result. Sine beta is sine gamma, sine alpha. Yeah, honestly, don't do maths when you've got a tooth abscess. It means that you do all sorts of crazy things and can't see the obvious. And that is the first 5 questions from the 2011 math. Hope it was useful. Keep up the hard work, and best of luck if you are taking the math. All the best. Bye-bye.